Okay, can you see my screen?
Yeah, your screen's coming in.
Yeah.
Both your collab and the book to the right.
Okay. Let's start then. Okay, this is like deploying your work, your models that you have worked before, and in some ways, good for me because I got lost with the last chapter stuff. They went over my head, but let's try if I can make sense of this chapter. Okay. So here it's we are going to deploy the models that we worked before and to make it to production. And it's some ways to do it is like use the tools from Google, and that makes this work a lot easier. And they're talking about some protocols like this one, REST API, that helps to escalate the deployment more easier, right? This is the REST API is a stateless protocol. It means that there is no information of the session in the server maintained, so it doesn't increase resources consumption in the server as it goes escalating. So the information is kept in the client, something like that. So, for example, I work with Oracle databases, and when you escalate the sessions, the consumption in the server increase very fast. So with these stateless connections, the escalation can increase much more. Okay. So you can use your own infrastructure, your own hardware, or you can use something from the cloud. Okay. Here, Jerome proposes to use the Google Cloud AI platform. Okay. And okay, the idea is to keep updating your models in production quickly, so you don't get stuck with a model that is performing slower and slower. Okay. And you should be able to train quickly the models. And use acceleration, of course, and GPUs or TPUs. One advantage of using the Google Cloud is to use the TPUs. They are usually faster than GPUs. Okay. And then TensorFlow has a lot of functionality to make this easy or easier than other solutions. Okay. And on this chapter, we're going to deploy models here in two ways, with TensorFlow serving and then with the Google Cloud platform. Okay. And then we are going to deploy models on mobile apps and embedded devices and web apps. Yeah, let's see that. It will be a quick look as per the comment here. And then we will use GPUs to train models. Okay. There is an API for distribution strategies. Okay. Okay. If somebody has experience with this and want to chime in, please do it. I have no experience with this, so you're very welcome. Okay. So let's start with serving a TensorFlow model. Okay. Okay, let's pause here to get a reading session. Okay. We can reconvene at in 15 minutes from now, and we want to read okay. Okay, until okay, deploy new version. Okay, until creating a prediction service on Google Cloud.
Is that including that one?
Yeah, including this one.
Okay.
All right. Okay. Let's make it 50 minutes. I reconvene that. That would be 11 a.m. Pacific time. Does it make sense?
Yep.
Okay, let me put my clock here. Okay.
Wait, we're going to read for how long? Sorry.
Yeah, up to 50 minutes, up to
50 minutes. So that would
11
be
a.m. Mountain
11.
Pacific.
Yes, yes. Okay,
Yeah.
brought it.
Yeah, my clock is on Mountain Time.
What time are you on?
Mountain Time?
Oh, Mountain, yeah.
Yeah.
That's an hour later than Pacific?
Yes.
I see.
Yes. Okay. Yeah, thank you.
Alvaro, will we get a chance to run through the code, including the Docker image locally and so on? I've hit some snags. I can't get the Docker image to run on my machine for this particular TensorFlow serving, so that's why I thought I'd ask.
No, I think there's two ways. One is with Docker, and the other is with Google Cloud. Google Cloud. I did not try the Docker version.
Okay.
I was looking at the Google Cloud, but I had issues with the Google Cloud earlier today that is trying to ask me to verify my account.
I've worked through these examples and I was able to deploy locally with Docker on TensorFlow serving and Google GCP as well. But perhaps, Mesh, you can share your screen down the road and perhaps we can debug it or something.
I'm happy to be the guinea pig for this session.
That would be great.
Mm-hmm.
Okay, time is up. Can you hear me?
Yes, we can hear you.
Okay. Had you chance to read through the until the section, the creating a Google Cloud service? Anyway, I won't be able to test that because I had some problems with my Google Cloud account. I'm waiting for the confirmation to verify. So, but anyway, let's continue. Yeah. Okay, so there is some advantages for this TensorFlow serving. So we can have several versions of the models. So we can keep the version stable across the applications and perform experiments between different versions. Okay, and separate the modeling, the training from the rest of the infrastructure of your production environment. So like we can see this diagram, right? We have applications connecting and interacting with the TensorFlow serving for different models and different versions of the models. And we have the models stored somewhere else. So this helps us to manage the models as we wish. Okay. In this code, you don't use the mnist as an example for the this setting of this configuration. Okay. 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 So there is a save function on TensorFlow saved model that saves the model on the file system, and we can then grab it up and use it. Okay.
Sorry, just to interject very quickly.
Yes,
If
please.
you guys see the model version, that's a very important thing to keep in mind. You should always, try to version model. But what Jiran did here is just kind of hard coding that in. But sometimes we could just use timestamps, import time and time.time, and then using timestamps as your model version. That could be one way of doing that.
Yeah, that will be great. So we can keep track of the versions across time, right?
Yeah.
Okay. Yeah, that's a good point. Thank you. Okay. So let's go to the code. First, let me enable the GPU here. Okay. And then this has some checks for requirements on the setup of this notebook, right? TensorFlow 2 and greater. And if anybody has any input on this setup, okay, let's run this guy. Okay, now let's use TensorFlow serving. Okay. Let's get a model saved here. Okay. Okay, and then train the model. This is the MNIST model data set. Okay, and then
so this one, he just runs model predict, but he says the first one is 100%, but the second one was 99%, and the third was 97%. How is that? Like the columns don't align. How did he say that? Did anyone pick up on that in the book?
yeah.
I think that's just probability prediction, right? For the classes.
Yeah, but it's just that the 100% for the first one is element number 1, 2, 3, 4, 5, 6, 7, 8 on the first item on the list item. And for the second one, the 99% probability is on the third item.
Right, that means it's number 3, right? It's predicting that it should be number 3, and for the first row, it should be class number 8.
Oh,
right?
okay. I get it now.
Yeah.
Okay. Thank you. I get it now.
Okay, thank you, Vietnam. Okay, so here's where Gotan Mega will point that we can use timestamp to keep track of the versions, right, of the model. And then delete anything old over there and save the model. And then let's see the structure of the directories. So we have the model name and then the version. And then we have the model file and variables and the assets. The assets may have some other files like graphs and stuff in there, or previous model samples, something like that. Then there is the disable model key is a command line tool from the tensor flow that gives us more information about the model. Okay, it's a serve, and then okay. I'm not sure what this, but I see that this is a model to be served or something like that. And then more details. So it shows the shape of the input. That's good to know. And the output, right? For the prediction. Okay. Then all the information. The functions in the model there. And the shades, right?
So just add a quick detail on this. Model signature is basically it basically outputs, as you have shown, outputs a bunch of details for a model. It helps you to debug what your model actually has. When when things get complex, a model signature does help with that. And also you can even do some customization with model signature as well. Yeah.
Oh, okay, so you can also modify some stuff, some configuration.
Yeah. Yeah.
Okay. Okay. Thank you. Okay. So it's shapes and make a save of these, and then the input name. So prediction testing here. Okay, here with a lot of decimal point. Let's round that output. We have like a number 2 here and number 7, a 2, and a 1, right? Now it comes the TensorFlow serving, and there is the Docker way, and can we go to the skip this one and do the for now and do the with the Google Cloud Google serving. Okay. Okay, we use TensorFlow model server. Okay. And I think this is this starting the background process to serve the models, right? And this is the port what is running. And let's see the log of that process running. Okay.
Yeah, sorry to interject, if you don't mind.
No, yes, please.
So what he is doing here is basically, and if you go a little above, Docker pull TensorFlow serving, and what you're seeing here is basically we're calling an image from Docker Hub, and that container has TensorFlow serving in it configured already. Everything is installed in there so that you don't have to configure yourself, and you can just pull that Docker image and use that container to run your local model and deploy it locally. Now, whereas if you do it on GCP, GCP kind of handles that process for you already, unless you want to customize your own container, which you can totally do for sure. But if you don't do that, you just want to use a TensorFlow model, and GCP will spin up a Docker container on the back end with TensorFlow serving for you, so that you don't have to do these processes yourself.
Okay, so it's better to make it more automate or something like that. Automatic?
Yeah, exactly. And of course, you have to pay for that. Yeah.
Okay.
Like in the Colab, it's the same, I suppose. We do not have to give our own images, and we can change it dynamically because the APIs are there.
Okay, it's like we're using here, right?
Yeah.
Okay. So we have the model, the server serving models here, and then okay. This I was not sure why is this doing the JSON dumps.
This is just basically the input data, and the XNew is saved for you to infer on. So the input data is just how you feed into your trained model in the TensorFlow serving, so that you can get predictions, basically. Yeah.
Okay.
Yeah. And so you can't just feed, some sort of a list or NumPy array. You have to feed in some sort of JSON file with signature name and instances. Yeah.
Okay, so we use like formatting in JSON way this information, right?
Exactly, and that's what most production environments do. I mean, when you get something from the front end, you don't get it in other formats. You get it in JSON, and this is what TensorFlow serving is doing as well. So.
Okay, so we get shown here, right? How is it that formed? Right.
Yeah, exactly.
Okay. Okay, and I see a number at the end of the list here. Not sure what is that, or what's the meaning of that? Is that like a signature number or something? Okay, let's continue then.
This might be the list for the x_new that we are getting.
This
This
one,
this list,
this number.
yeah, it might be a part of this guy here. So I think so. If we look at the data type, this will represent the input data. Since we have represented this input underscore data underscore JSON uh, uh, from 0th index to uh, 1499. So that will be there, and it will be the instances. Instances has a three. I think so. Yeah, it's three-dimensional. So it's the inner of the inner of the inner. It's the uh, third inner dimension which has this value. This, I think so, represents the uh, data JSON with respect to the. This is to simply we have converted it to this, and then we are uh, mm, uh, going to send this as a response to the our server. So this is a kind of a format in which it's represented.
Okay, so you can take a look at if it is has the structure that you expect, right?
Yeah. Yeah. If you go to the next statement, yeah, we can see that the input data JSON. Yeah. Here we have requested this as a post. It's going to the server. Yeah.
Okay. So we check the what are response keys, right here.
Yeah, this is a kind of a since it is predicting the MNest. So yeah, this will be the images, I think, which are going in uh, to give us the response.
Okay. So this is the predictions, right?
Yep.
Okay. Same thing. Okay, now it's using the API, the gRPC API from Google. and import this guy, and then import this other one, and then okay. Response. I'm not sure what it's doing here. Is like showing the values of the response.
It's simple JSON response type. Sure.
Okay. Anyway, here is the conversion, right?
And this is the prediction with respect to those 9 class values. 0, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah,
Sorry, 10. The MNEST
0 to
digits
9. Yeah.
0 to 9. 10.
Yeah. Okay. Okay. Then using an NumPy array, same thing. Okay. Now a new for a new model version, use training this model, and then the trick is to use a different model version value, right? That, as Gautam pointed, is good to. Maybe it's better to use a timestamp because it will be difficult to like be naming the numbers, right?
Right, exactly. You want to try to name it automatically. And the other thing is perhaps it's also good to add in the data version. So basically right now, the best practice is to version your model and version your data and version your codes. And certainly your model should be aligned with the data set that it was trained on. So perhaps it's also good to, kind of link the model version and data version together.
Okay.
Yeah.
Okay. Something here in the naming, right? You mean, right?
Yeah, it could be, yeah. For data version, people now use data version control, DVC, to do it. So perhaps there's some ways that we could link model version and data version together. Yeah.
Okay. Or maybe changing by the model name or something like that.
Model name, well, model name should just stay the same. But you would add, if you see os.path.join, it's just adding the model name and model version together. But I think it will be convenient to kind of know which data set this model was trained on.
Okay.
So yeah, exactly.
Okay. So keep it on the model name. Keep all the versions and data set versions and
exactly.
that. Okay.
Yep.
Okay. So we see the path here. The assets updated under the version 2, and then see all the structure under that. So we have, for example, here the model name and then the versions. Okay. Okay. So in this way, we can choose to have, for example, let's say we have the model, and then we have beside the timestamp, we can have like a data set, type of data set, version 1, data set version 2, something like that.
Yeah, it could be. And I think that's a good way to do it. Just so you know which data set this model was trained on, because your next model version could be trained on a different data sets version. And data sets evolve as well when you find new features and adding different features and stuff. So
okay, see, for example, you can say like you can have later like the model name and then let's say dataset version 2 whatever, and then
Yeah, exactly.
times
Yep.
1, times 2, times 3, something like that.
Sure.
Okay.
Yeah.
Okay. And then the TensorFlow serving here. Okay. Same thing, and then the prediction, right? Okay, same thing. Okay, I was not able to test these deploy to the Google Cloud platform. I had an issue with my Google Cloud. I'm waiting for the verification. But Gotan, you were saying that you can show with my hash something with Mash, something like troubleshooting the Docker or something like that.
I don't think Gotham is here.
Oh, sorry. Sorry, you Wenchang, right?
Oh yeah, I
Sorry.
didn't realize you were speaking to me. Okay.
Sorry.
What was your question? Sorry.
Yeah, I think Mash said that he has a Docker that is not working for this, and you were saying that you can probably.
Yeah, I can. Yeah, exactly.
Yeah.
I can help anyone to debug this if anyone wants to share screen or whatever.
Yeah.
Yeah, I'm happy to help.
All right, I can share screen if you guys
Let me
want.
stop my sharing. I think I did.
And I will share mine. Desktop 1. There we go. So what I've got here is, of course, the Jupyter Notebook. By the way, Wencheng, thank you so much for sharing the DVC.
Yeah.
I wasn't familiar with it, but yeah, this is exactly what model tracking, model management, and so on are critical aspects.
Mm-hmm.
So here's the latest version. So in any case, my code locally did not finish because it's not running the Docker. And so to run the Docker, what I did was simply just go and do Docker pull for TensorFlow serving. It pulled it, downloaded it, and got up to running the command that he had put in. So Docker run with the specific commands, but I think I'm beginning to understand why. No, this should have worked. So this is here's the latest code, latest command run. Let me know if you want me to make it larger, Wencheng.
Yeah, that's fine.
So Docker run -it-rm, so remove any other images, and then run with ports 8500 to 8500 and send to ports 8501 to 8501 -b. And then I wonder if I needed to define ML path.
Yes, that's the
Yeah, that's probably it.
yeah. Up till the path of the directory of the project, the hands-on ML directory.
You have to use your own path.
Yeah.
Got it.
Yeah.
My own path. Okay. So define the path. Okay, and where we're going to put that in. What's the command for writing your own path?
Well, you can. Well, first of all, get the current path by typing in pwd. Just delete the the entire line. Just get pwd.
No, okay.
Yeah.
I know what the path is. It's
Okay.
just dash code. So why don't I just, since I already know what pwd would give me, let me just put it right there.
Yeah.
Okay. This should work. No. Why? Path is not shared from the host and is not known to Docker. Docker is running.
Yeah, your Docker should be fine. Can I look at the terminal again?
Sure. Sure. Let me go this way. Go ahead.
Mm.
Could you open a new command, this
Yeah.
terminal, and
Sure.
type in Docker space status? So it will show the.
I just put in Docker ls. Docker ls.
Docker space status.
It doesn't give me anything, which is like I've got this Docker is running, but
Put in Docker container ls. Docker container ls. There you go. So it is running. It's probably your path. Can you get just type in pwd?
That's why. I think you have to specify the entire path.
Yeah, exactly. That's what I had to do. The absolute path.
Absolute path. Thank you. There we go. But this is
no
different
versions of servable. So it says no versions of servable. Can you open up your directory to see if there are model versions there?
I wonder where the Docker actually put it in. Did it put it in downloads or did it put it in code? Here. Yeah, my MNIST model, but there's nothing in there.
There's nothing in there.
But that was what's created right now. When it downloaded the Docker image, isn't that where it's supposed to go?
No, so in that folder, you should have the trained models saved in them. Then Docker image is something that goes somewhere else under Docker. But basically, it's not able to find any models, and rightfully so, because you don't have any models in that folder.
Okay.
Yeah.
So now if I were to run this cell, nope, still fails because this is where we would put the models.
Yeah. So under my minutes models, you should have 0001, 0002, and a bunch of folders like that.
Got it. Do you have it set up, Wencheng? I think by the time I get this set up, it'll just waste everyone's time.
I can share string.
Okay.
Yeah. Let me just try to do that. So yeah, so just like this, right? So your save the minute, I call it save the minutes models, but basically these two versions are what I have. And what I meant by the model version is I just use time integer that's string that, so that all these are timestamps in a stream version of timestamps. And this is the command I ran. So if you look at that, Docker run it, and this is the absolute path. User Wencheng Dropbox, and this is the project folder, minist ML pipeline, and saved minist models. And models saved minutes models. So saved minutes model is this, and minutes ML pipeline is project folder, right? So yeah, but normally you wouldn't infer from locally. I mean, you don't deploy your model locally. It's just what it is. So yeah. Any other questions? And I actually just did a demo with another meetup in terms of deploying models on GCP, but not for Minist, because we don't use Minist in real life anyway. So I did it with a classification model using neural networks. So structured tabular data, but using neural networks to solve it and deploying it on GCP and infer it. So I did a quick talk on that.
All right, Wencheng, you got to do that talk for the rest of us.
Yeah, that would be great.
Yeah, we'd love to do it. And if you look at GCP prediction, that's how you do it, right? Basically, it's some sample code from GCP, but just to get it set up, and you gotta save the JSON file as your credential, which is your service account's credential, and specify the API endpoints, and have the model names. And in the end, then you can, this is how you predict with this data set Minist. You specify the region and your model and your version. I'm just adding a V in front of that timestamp and passing in the instances, then you should be able to get it. Okay. And make sure you turn it off, whenever you do that. Because it actually charges you money. So some of the stuff from that book has changed since the book came out, such as if you're not careful enough and you put in the region, and if you don't specify the region here following Jerome's instructions, then you wouldn't be able to get predictions. And the other thing is, when Jerome wrote the book, I think GCP might still allow people to have minimum of 0 instance, meaning it will be turned off or spun up automatically if you are not using it or just using it. But now the minimum instance is 1. So if you leave it on, you'll be charged hundreds of bucks per month. So just FYI on that.
Yeah. Plus, I would like to add there are quite a few new notebooks that have come up in the examples section of the TensorFlow serving, which I used to play around with, and you can take a look from there too, with respect to deploying the NLP models and as vision models as Wenchang just uh, showed us. So there are multiple configurations with respect to deploying it on Kubernetes and scaling up. And so if you want to go that route, there are example notebooks which give us the configurations and the distributed multi-worker settings. So just to add to that.
Yeah, absolutely. That'd be cool.
I have a question here. What if you want to the last version? Let's say you want the last version, whatever that version is. How can you query that?
Yeah, so I think TensorFlow serving will automatically detect that. And what I'm guessing is it will automatically detect the latest one. So if you use timestep, it will automatically detect this is the latest model version and it will just
Okay.
use that as a default model version. And it's
Okay.
similarly, if you do 0001, 0002, and it will most likely just use 0002 as your latest model version. But on GCP, you should be able to specify that in terms of the default model. Well, in terms of the model version, right? So, yeah.
So if you remove the version, it will pick up the latest, right?
Yeah, most likely, but I suspect, and if you look at this is a required, well, actually, this is not a required argument. So yeah, most likely.
Yeah, but
Yeah.
yeah, and just to add, in production settings, we cannot take it for granted. Maybe with respect to the timestamp, something might change, so it's better to explicitly give the version number with respect to timestamp as.
Mhm.
So that's the best practice and the best approach.
Absolutely. Yeah, you should always specify the version.
Yeah. What if? Okay. Yeah. Maybe. What if one team is doing the modeling and another team is doing the deployment here and or the predicting? There need
What
to
do you
be
mean?
some communication, right?
Yeah, so that has to do with orchestration. I don't think he talked about orchestration.
No.
Yeah, so that has to do with TensorFlow extended. There's a package called TensorFlow extended. TensorFlow extended. So, and this is the end game. Basically, if you wanted, building ML pipelines is not the ending part. In the end, you still have to, you want to orchestrate it, and this is how enterprises do it, by using something like TFX or Airflow, right? And some companies have Airflow for other tasks such as data engineering or data pipeline tasks, so they might just use Airflow. And but some companies already adopted TensorFlow and Cube, then they just use Kubeflow to orchestrate the pipelines. But the way how you build up pipelines is through, in terms of TensorFlow, is through TFX. And this is a great website, and you can see example gen, statistics gen, schema gen, example validator, transform, tune, trainer. So example gen is where you're kind of feeding the data. Validators, and this is where you kind of do some statistical stuff, processing stuff. And in schema gen, example validator, you kind of validate your data sets. You always want to validate your schema, and in terms of, is it even present, right? And what about the missing values, and what about the distribution, right? If there's distribution shift, such as uh, something that's caused by COVID-19, right? And everything changed, people's behavior changed after COVID-19, so a lot of the models might not even work. So you want to validate some of the distribution, and then you transform that, do more processing. And this part allows you to kind of align your train serve pipeline by using TF transform. And then you kind of train it, tune it, and these all are part of TFX package, which is under the TensorFlow ecosystem. And so there's much work to be done after you train your model, and there's evaluator and pusher. This is where you push your model eventually to a platform like GCP. Yeah. And this is the topic that I will start covering with the new group, ML pipelines, on April 7th. So
Is this TFX only a libraries, or is this also a service that you have to pay?
yes, it is a library under TensorFlow ecosystem. And if you look into the API document, you can see tfx.components, orchestration types, and if you look into the components, there are lots of components you could do. CSV example gen, I mean, just from the name, you know it's that allows you to generate, you know, some sort of object with a CSV file so that your TensorFlow pipeline can ingest that. Okay.
Does this require any service from Go or something like that?
What is Syrupy?
Any service, any expenses, additional?
No, these are all free, open sourced.
It's only libraries, right?
Yeah, these are only libraries.
Okay.
And yes, it only, and even Kubeflow, Airflow, they're open sourced tools. Only when you use the GCP service, and then you incur some costs. And I was again, this was a kind of a sample project. I did a talk for fraud detection classifier, and in the services you need to deploy your model is, you know, you want to store your model in a cloud storage. So cloud storage is just like a S3 buckets, and that's where you store your model. And you kind of then you go on to like AI platform models, and this is where you kind of create a model and then create a version of that model and link that to your cloud storage. So kind of providing a link to where your models actually store. But this the model platform from underneath the AI platform kind of provides you an endpoint so that you can call this function, predict JSON, and start inferring from your model. And IAM is where you kind of create your service accounts, and then you can download your credentials and stuff. So yeah.
Okay, thank you.
Sure. All right, stop sharing.
Okay, the next part of the chapter is exactly that, creating the using the Google Cloud platform, and it's not working for me. Hopefully, next few days it will be done and ready, so we can show that and continue next week.
Thank you.
Okay, thank you very much, guys.
Thank you.
Thank you.
Thanks, Alvaro.
Thanks very much.
Hi, everyone. Stay safe.
Thank you, Wensheng.
Yeah, no problem. Bye-bye.
Bye.